purpose of this video is to give you a little bit of background information to help you get started on the homework, since we don't have time in class to talk about it. Okay, so we're looking at the number families inside the set of real numbers. The two main subsets under real numbers would be irrational and rational numbers. An irrational number cannot be written as a fraction. So you cannot write it as a fraction. A rational number, the root word of rational is ratio, so a rational number can be written as a fraction. So you're given some numbers over here, A through K, and you're asked to figure out which category or which subset they fall into. The most famous irrational number is pi. The pattern, it never repeats, you can't predict what's coming next. So pi is the most famous irrational number. Radicals, square roots, they're not perfect squares. The square root of -10 would be an irrational number. It would be a decimal that you can't predict what's coming next, and you cannot express the square root of -10 as a fraction. And to give you a few examples that are not listed, the square root of 2, the square root of 3, the square root of 5, those are irrational numbers. It's not possible to express any of those values as a fraction. Now let's look at the rational numbers. Rational numbers are broken down into subsets. So if I were to think of the number line, I could have -3, -2, -1, 0, 1, 2, 3, and going on in the directions of both positive and negative infinity. Rational numbers would include values like 1/2, or 3/2 here, or -1/2. So my rational numbers would include everything that's in green as well as all of the fractions in between. The integers are just simply -3, -2, -1 in the direction of opposite infinity, including 0, and then going on and picking up my positive counting numbers. So those are my integers. Whole numbers are all of the integers, the positive integers, including 0. So here are my whole numbers. And then my natural numbers are just simply the counting numbers that you learn in kindergarten. So these are your counting numbers. So it does not include 0. So the rational numbers include all of the integers and 0, as well as all of the fractions in between each of those numbers. Those are your rational numbers. Your integers are your positive counting numbers that you learn in kindergarten. You pick up 0, and then you do the opposite of all of the counting numbers, -1, -2, -3, on in the direction of negative infinity. To come down one level to just whole numbers, well, all of the negative numbers drop off, and you start with 0, and then you include all of the positive counting numbers. Those are your whole numbers. And then your natural or counting numbers, 0 falls off, and you just start with the numbers that you learned in kindergarten. So you're given A through K, and you're asked to separate these into the subsets. I guess the least most subset that they belong to, the innermost subset. So let's do some of these together. A, +7, well, that is a natural or counting number, so I would put that down here. B, well, that actually simplifies down to -3. That's not a counting number. It's not a whole number, so it falls in the category of integers. C, well, the square root of 36 is 6, and there's a negative sign in front of it, so that's really just an integer. It's not a whole number, it's not a counting number. D is irrational. 6.48, that is a decimal, so that falls up here under rational. So rational numbers include the fractions or decimals that repeat or end. So if it's a repeating pattern like 0.3 infinitely, that's a rational number. E is a rational number. 6.48 is a rational number. F, -2, that's just simply an integer. The square root of negative 10, that's an irrational number. H, 0. I'm going to put that in whole numbers. Whole numbers. 2 and 1/6. All right, there's your mixed number. It's not an integer, so I'm going to put this up here with my rational numbers. 0.7 repeating. Well, it's a predictable decimal pattern, so I would consider that as rational. And then finally, we'll study this at some point this year, but 4 is a positive square. 81 is also a positive square. The square root of 4 is 2, and the square root of 81 is 9. So the value of the square root of 4 over 81 is actually 2/9, and that ends up being just a rational number. And you've got a set of these to do by yourself, but this should hopefully be enough information to get you started on that. And as always, any questions you have, we will do them in class together, so bring your questions to class. Number 1, which expression does not name an integer? Well, negative 15, this is true, that is an integer. 0 is an integer. This simplifies to positive 2, that's an integer. So that means that B, even if I simplify that fraction, I have 3 over 7. So the answer here is B. Number 2, which expression represents an irrational number? Well, the bar above 18 tells me that it repeats, so that is not irrational. 2 over 3, I can write that as a fraction, so that is not irrational. I would consider that a false statement if I'm looking for an irrational number. The square root of 3 minus itself is actually 0, so that's not irrational. That leaves me with the square root of 75, so my answer here is B. And number 3, which is not a whole number. Remember, the whole numbers start with 0, and they're all of your positive counting numbers then. So let's see, D, 18 over 3 is actually 6, so that's fine. So that means my answer here, once again, is B. Negative 10 is not a whole number. And hopefully you can finish the rest of these by yourself, and you can always email me if you have questions.